Hello students, now in this session I will explain sum number 3 and 4 of exercise 7.1 chapter 7 cubes and cube root. Now in question number 3 you have to find out the smallest number by which you have to multiply the following numbers which are given to obtain the perfect cube. So what does it mean? It means that the numbers which are given, these are not a perfect cube, but you have to make it a perfect cube. And how you have to make it a perfect cube? By dividing with a smallest number. Fine. So what is the process? The procedure is very similar to the question number 2 only. The first thing that you have to do, you have to find out the factor of 81. That is 3 27s are, 3 9s are, 3 3s are, 3 1s are. Now the next step, you have to write all the factors of 81. 3 into 3 into 3 into 3. Okay, now the next thing, you have to form a triplet, but this 3 is not in the triplet form, so obviously the smallest number would be 3 now. But before that you have to write here 3 cannot be grouped into triplet of equal factors okay. So therefore we will divide, that is 81 by 3 to obtain a perfect cube. That's it. So what is the smallest number? The smallest number is 3. Okay, so now let's move on to sum number 2. Sum number 2, we have 128s. Okay, so what we have to do? We have to first find out the prime factors of 128. So 2 64s are, 2 32s are 64, 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So there are 7 2s are there. 1 2 3 4 5 6 7. Yes. So 128. So 128 can be written as 1 2 3 4 5 6 7. Now what we have to do? Yes, we have to form a triplet. So we can see that 2 is not in the form of triplet. So what we can write? We can write here 2 cannot be grouped into the triplet of equal factors. So what we have to do? So we will divide this number, that is 128, by 2 to obtain a perfect cube. So what is your smallest number, students? Your smallest number is 2 only. Okay, so let's do sum number 3. So sum number 3 is 135. So let's find out the prime factors of 135. So it is divisible by 3. So 3 4s are 12, 3 5s are 15, 3 15s are 45, 3 5s are 15, and 5 1s are 5. So we'll write the factors of 135, that is 3 into 3 into 3 into 5. Now what we have to make? We have to make a triplet. So as we see that 5 is not in the triplet form, so what we can write? We can write here 5 cannot be grouped into triplet of equal factors. So therefore we will divide 135 by 5 to obtain a perfect cube. Okay, it's as simple as this. Now let's do sum number 4. Sum number 4, we have 192. So we'll get the prime factors of 192, students. So 2 9s are 18, 2 6s are 12, 2 48s are, 2 24s are, 2 12s are, 2 6s are, 2 3s are, and 3 1s are. So we'll write all the prime factors of 192, that is 1 2 3 4 5 6. 6 2s are there and 1 3 is there. So it is quite clear that all the 2's are in the triplet form, but this 3 is not in the triplet form. So we'll write here 3 cannot be grouped into the triplet of equal factors. So we will divide 192 by 3 to obtain a perfect cube. Okay. And sum number 5, you all try it on yourself. Now let's try to understand sum number 4. Now in question number 4, there is one cuboid is given whose length, breadth and height is given. Fine. Whose length is given 5 centimeter, breadth is given 2 centimeter and height is given 5 centimeter. Now they have asked that how many more cuboid like this, okay, how many more cuboid like this you will join together, okay, to form a big cube. Okay, so as you see, the first thing that we will find out is what is the volume of this cuboid. Okay, so volume of the required cuboid is length into breadth into height. Okay, so what is length? 5, breadth is 2 and again height is 5 centimeter cube. So this is 50 centimeter cube. So as we see that the volume is not a perfect cube as because it is a cuboid. So how to make it a cuboid? How to make it a cuboid? So what is the logic? That this all the numbers should be in the triplet form. In that way only we can make this number a proper cube, isn't it? A perfect cube. So we'll first find the prime factors. So we'll do the prime factorization of number 50. So that would be 2 into 25, 5, 5, 1, 7. Okay. So what are the prime factors of 50? That is 2 into 5 into 5. Now as we can observe here, neither 5 is in the triplet form nor 2 is in the triplet form. Fine. So if any number whose prime factors are not in the triplet form, so it's quite obvious that the required number is not a perfect cube. So to make it a perfect cube, so this what we have to do, we have to make this 50 a perfect cube. So how to make a perfect cube? So we have to multiply one more 5 here. We have to multiply one more 5 here and 2 2's also. That means it should look like 2 into 2. This is what we have to add, and 5 into 5 into what? 5, isn't it? So these are all the numbers which are written with red pen. These are all the numbers we have to include here so that to make a 50 a perfect cube. So which are the numbers we are including? That is 2 2's and 1 5. So when we are including this number on the right hand side, the same thing we have to do on the left hand side also. That is, we have to multiply 50. We have to multiply 50 with what? 2 into 2 into 5. Fine. So in that way this 50 will become a perfect cube number. But for now what we will write? Hence we will write here 2 and 5 cannot be grouped into triplet of equal factors, isn't it? So therefore we will multiply 50 by what? 2 into 2 into 5 to obtain a perfect cube, isn't it? So from here only we can say that how many more cuboid like this, that is what was the main question, that how many cuboid like this we can join together so that we can get a huge cuboid. So what is required? How many cuboid? That is 2 into 2 into 5, that is 20 such cuboid we require. So hence 20 cuboid is needed. So we will write hence 2 into 2 into 5, that is equals to 20. So hence 20 cuboid more is required or needed. Okay. So that's it for today, students. Thank you. God bless you all and take care, everyone.